Hi, this is Mark No from NetNumber, and we're here at Mobile World Congress 2018, and this is the NetNumber booth of which we have a Private LTE live demonstration. So I'm going to step you through that. So the markets that we are typically seeing the most activity in with Private LTE is around defense, public safety, and as well as transportation. The use cases that you would normally hear about and that we support are typically VoLTE and voice over Wi-Fi, but also SIP Digest has a lot of interest as well, particularly customers that really aren't ready to take on VoLTE completely. SIP Digest as a data over LTE application or over Wi-Fi is interesting. So what we're demonstrating here, we have a setup using these compact, hardened PC platforms. You can buy these on Amazon. These are from CompuLab, but basically these are what would be used in like a Humvee or on a backpack for a platoon or a squad in defense, or maybe on a fire truck for public safety. So we have our Titan Edge using our Titan Master Edge architecture. These are two of our edges, and these could be thousands of remote sites, or a lot of the applications in Private LTE require a large number of edge locations, whether it's vehicles or what have you. And then we have what we call our data center component. So with the data center, we have our master, and we also have a data center edge function, which just could just be a VM right next to the master if we wanted. So let's talk about how this works. So we're running on this edge. This is for this particular example, this is Ubuntu with KVM. So it's virtualized. On one VM we have the HSS, our distributed HSS solution, as well as our IMS core and ENUM-DNS. So that's all running in one virtual machine. It's a very small footprint. Typically with Private LTE off an edge location, you probably have under 100 subscribers. So it doesn't require a lot of compute resources for this. Now also on these, in a neighbor or adjacent virtual machine, we have an EPC. With our partner, Surround Communications, they've provided us an EPC that we've put in here as well. So on these two edges, we're connecting up to, we have the option of using a eNodeB here, where we actually have powered down band 20, and this phone right here will be connected up via LTE, and as you'll see in the bars here, he's connected over LTE to this eNodeB, and this one in particular is registered to Titan Edge 1. This phone over here is over Wi-Fi, and this particular phone is registered over here to Edge 2. So this could be an example of two soldiers, one in one squad and another one in another squad, or maybe it's a fireman that's in one fire truck and the other one's in the other fire truck. So one of the beauties about our Titan architecture is it is a locally an autonomous edge solution, and what we mean by that is we don't need an uplink to provide local services. All of the phones or subscribers that are locally subscribed on this work regardless with video and voice services, if the uplink's there or not. And a lot of times the uplinks in these scenarios are satellite, or maybe LTE backhaul or microwave, and it's very possible that these uplinks or links may go away and come back depending on the conditions, right? So that's definitely one of the advantages of the Titan architecture. And so if a subscriber is locally registered, it's just a local call, right? All of the processing sits here. So it's kind of like a PBX in a box in a way. If the subscriber is making a call to another subscriber that's not registered locally, what we'll do with the IMS is we'll send that SIP invite up here to the data center, like over satellite or whatever IP solution for backhaul that they have. And at the data center we have an ICSCF function that will determine where that subscriber is, forward that SIP invite to the right remote edge, and allow that control plane connection to be completed. From there on though, it's just RTP IP direct between the clients over whatever the IP medium is. Now, One of the key capabilities that we have in this architecture is at the data center with the Titan Master, we provide an API that permits all of your subscriber provisioning to be easily imported into the database of the master and then replicated very efficiently over the satellite, optimized, compressed to the remote edges, and it's transparent. You don't, users that have this solution, or customers that have the solution, don't have to really touch the edges to manage the subscriber. So it's all done automatically via the master, and via the API makes it very easy to maintain and easy to operate. So with that, why don't we go ahead and give you a demo. So as I mentioned before, on this phone we're on LTE and registered to Titan Edge 1. On this phone we're on Wi-Fi, registered to Titan Edge 2. So we'll just do a quick video call. Everybody can use voice or video. Now what we're using here is a SIP client called BRIA. So we're going to demonstrate a SIP digest data over LTE, kind of an over-the-top solution that many customers are interested in doing this, using a client, even their own client or many of the off-the-shelf client solutions, because it's easier than implementing a full VoLTE solution today. But it's important to note that with our solution, we're VoLTE ready. So customers that decide maybe to not invest completely in VoLTE, they have a investment protection, and they can move to VoLTE in the future. So for this, let me just go ahead and Bidium 1 here. And by the way, these Bidium handsets, these are mil-spec hardened handsets that are commonly used in public safety. So I will go ahead and I'll do a video call over here. I'm going to answer that call, send video both ways. And so we just made a call between Edge 1 and Edge 2, via the data center and the IMS control plane, and now it's just direct RTP, and we're actually just going over a common IP hub that's connecting these two edges together. That would simulate satellite or microwave or whatever the IP backhaul solution is. So while I'm on this, let me just kind of give you a demonstration of the TAS capabilities that are built into some of these clients. And this is an important point because usually in public safety there's a small number of subscribers that are off the edges, and there's a small number of TAS capabilities that they require. They may not require all of the traditional telephony applications that you would normally expect. So for an example, if I bring up on this client, I could transfer this call. So having the ability to transfer is built in this client, and as well as the ability to conference. And also, this is Android. The clients are supported on iOS. This could be desktop Windows machines. It could be Macs. There's a client basically that's usually built across the board with these SIP clients off the shelf, and that's the case here for the BRIA client. So let me go ahead and I will pick up this iPhone here, and let me make a phone call. So I'll call. Let's just do a voice call here to Bidium 2. There's the call coming in. Now when I answer that, immediately he puts the original call. Sorry. Immediately he puts the original call on hold, so now it's just these two talking to each other. Now I have some options here. I could transfer this call over to some other subscriber, or I can conference. So if I do a conference, I can it drops the video because it can't do multi-point video on the conferencing, and now we have a multi-point audio call. And obviously we can keep doing that with more subscribers. So transfer, conferencing are built into this solution. And just multi-line and some basic capabilities that you would typically require for public safety. And then also on top of that, as you'll see in messaging, that these support messaging as well, and these are messages that have been sent between the clients, as well as presence. So there's a lot of strong capabilities that are just built in on a peer-to-peer basis in these SIP client applications, which makes it even easier to implement private LTE because you don't have to throw in a TAS or other application. Now, one of the features that you're going to need in certain enterprises is push-to-talk, as well as in public safety. In that case, actually, it would be mission-critical push-to-talk. And those standards are being developed now or maturing right now in 3GPP standards anyway. So one of the things we're going to do is add to this. We have some partners that are coming into play that will be able to add an enterprise push-to-talk such that that would be another application in a VM. I think I may have mentioned earlier that we can containerize the Titan Edge on Docker. So you'll find that many of the application providers like an EPC, etc., will also be able to fit in under a container architecture as well. When you do have a push-to-talk solution, Bidium already has some mission-critical push-to-talk testing that's been done. So you would be able to find that in here, and it would be an application that's sitting in a VM on the edge to enable that function. So you would get a phone, Sona, Bidium, whatever it may be, with mission-critical push-to-talk, as well as all of the SIP type capabilities for voice, video, and the task function type mission. So we'll be adding those to probably for our next demonstration in London in June. And that's our demonstration at Mobile World Congress 2018. Thank you.